Hello and welcome. We are doing a flip teaching lesson today, which is where I have a video of the content of a lesson that you're going to watch at home, which hopefully you're doing right now, and that way we can spend our valuable class time trying some examples and doing some problems and solving some additional things, additional kinds of problems. So our objective for today is to basically look at what's going on in our book at chapter 4, which is linear systems. We're going to define what a linear system is. We're going to learn to solve linear systems. And we have 3 different methods. One's transforming equations. It's called linear combination, where we combine 2 or more equations to reduce the total number of equations that we have to solve. The other is a substitution method, which is a separate video on my website for that one. And the third is a graphical method. Okay, so let's go to our next slide. Okay, so here, sorry for the delay there. Here is a definition. I'm not sure if you guys have this or not, but I'll go through it. If you don't, we can get this in class. So a system of equations or inequalities, they can either be equations or inequalities. There can be 2 or more equations or inequalities that have the same solution set or variables, okay? I'm sorry, not solution set, that have the same variables. So, for instance, here's an example of one. We have 2x minus y equals 10, 3x plus 2y equals minus 12. We have 2 equations. They're both linear because, see, neither of the variables have an exponent on them, so we know they're linear. And they have the same variables, x and y in one equation, x and y in the other. So that's all a system is. And okay, so that's the definition of a system. And then the solution set is going to be the set of all ordered pairs, all values of x and y, that satisfy the equations or inequalities in the system. So we'll hopefully find some points there and show you what we're talking about here. Okay, here's an example of a system of linear equations. They're linear because both variables, you have an x and y in both equations here. This is a system of linear equations because we have equal signs. And they're linear because both x and the y are to the first power. We don't have any squares or cubes or any fractional powers up here. Okay? So this first method, linear combination, what we're going to do is combine these 2 down to one equation with one unknown. So we can either get rid of the x or get rid of the y. And so here is linear combination method. So what I want to basically do is take one of the equations and get it so that the coefficients are the same, so, or opposite of each other. So, and we'll explain a little more here. So what I would like to do is take this equation and I'm going to multiply it by 4, okay? That didn't work very well. We'll put a 4 there, we're going to multiply by 4 over here, okay? So now what we're going to get is 4x minus 4y. So we have 4x minus 4y equals minus 44. Okay, so once again, I just multiplied the top equation, both sides, by 4. Now I'm going to add these 2. I'm going to combine these, and watch what happens here. 4 and 7 is 11x. 4y minus 4y is 0. So we don't have any more y's left, which is exactly what we're trying to accomplish. And now we have minus 22 plus some minus 44 is going to give us some minus 66. Okay. So now we have 11x equals minus 66. We divide this by 11, divide this side by 11, and we get x equal to a negative 6. Okay? Not quite done. We have to still find out what y is. So now that I know that x is minus 6, I can either plug it into this original blue equation or this one. Doesn't matter which one. Looks like maybe that original equation would be a little bit easier. So let's just plug x equals minus 6 into here. Okay? So that's going to leave me with minus 6 minus y equals minus 11. Going back to my original equation in blue. So let's solve this. We're going to add 6 to both sides. And we're going to get minus y equals minus 5. And if I multiply by both sides by minus 1, I'll get y is equal to 5. So now our solution set, remember solution set was a set of all ordered pairs that satisfy the system. So our solution set, big S, is going to be equal to minus 6, 5. Okay? And now if I plug a minus 6, 5 into our original blue equation, we should get a true statement, which we just saw that we will. And if I also plug this into the second equation, we should get a true statement too. minus 6 for x is going to be minus 42, and 5 is going to be 20. So minus 42 plus 20 is a minus 22, and minus 22 equals minus 22. That's true. So that is our solution. Okay. What I'd like you to try, we'll do it in class, but graph these two equations. On your calculator, you have to solve these both for y. So if you solve them for y, then you can put y equals on your calculator. Solve these two, graph them, and what we should find is we have two equations, and they intersect, two lines, and they're going to intersect at the point minus 6, 5. So that's the one point that is the common solution for these two equations. Okay, once again, the secret is to eliminate a variable, to make the coefficients of one or the other the same, one of the variables the same or opposite. So one thing we can do is we can multiply this bottom one by 3, let's say, and add these two together, and the y's will drop out. Because we'll have plus 3y and a minus 3y. Let's go ahead and do that. Wouldn't hurt to see another example. So I'm going to multiply this bottom by 3 and the top by, the right and the left by 3. So now we're going to have, doing that, we're going to get 15x. We're going to get minus 3y equals minus 24. Okay, and if I add these two together, I'm going to get 15x plus 4x is 19x. My y's drop out, and I'm going to get minus 24 plus 5 is a minus 19. Divide by 19. I get x equal to minus 1. Remember now I plug the x equals minus 1 into either the blue equations here. Let's plug it into the first one, doesn't matter. So we're going to get 4 times a minus 1 plus 3y equals 5. Let's solve that. We're going to get minus 4 plus 3y equals 5. I'm going to add 4 to both sides. Add 4 and add 4, and we'll get 3y equals 9. Therefore, y equals 3. So our solution set for this one is the ordered pair, x equals minus 1, and the y value is 3. Once again, if we graph those, we should see two lines, and the place where the two lines cross is going to be at the point minus 1, 3. What this is saying up here at the top here, or at the bottom here, is if we either subtract the equations if the coefficients are the same. So if somehow I'd set this up so that this 3y and this ended up with 3y. If I multiply by minus 3 here, I would have minus 15x plus 3y equals plus 24. And then what I'd have to do is subtract this equation from that, because we'd have 3y minus 3y equals 0, and so forth. So try that out. I think I may have another example or two. Yeah, let's try a couple examples quickly. I'm trying to keep these videos to 10 minutes so I don't lose your attention. So let's try the first one here. Once again, we probably pick a value, and a good value to pick here looks like it would be 3, and multiplying the second equation by 3. Okay. So what we're going to get now is 6x minus 3y equals 0 times 3, which is 0. Put our original equation, x plus 3y equals 28. That's this original one up here. And now we're going to add these two because they have opposite signs here. So I'm going to get 7x plus 0 is equal to 28, or x equals 4. Remember, our solution set is an ordered pair, so we have to find out what y is. So I'm going to plug this 4 back in up here, and I'm going to get 4 plus 3y equals 28. Subtract 4, get 3y, then equals 24, or y equals 8. So our solution set for this one then is 4, 8. That's an ordered pair. And once again, if I plug 4, 8 into this equation, I should get a true statement. If I plug 4, 8 into this equation, I should get a true statement, and I'll leave that as an exercise for you to try. Okay, one last one is this one down here. So now we notice what we have, we can't just, this is a different situation. We have to get a common coefficient for these. So I can either, we want to look for a common denominator of either the 4 and the 9 or the 5 and the 3. It really doesn't matter. Let's eliminate, we can eliminate either one that we want. But I'm going to go ahead and try to eliminate the y's. So a common denominator between minus 5 and minus 3 would be 15. Okay? So what that means is we want to multiply this top one by 3. Remember, we have to do both sides of it. And we want to multiply the bottom one by 5, okay? So hopefully why I'm doing this will become clear in a minute. So doing this now is going to lead to 27x minus 15y equals 3 times 26, which is going to be 78. Okay. Here I'm going to multiply 5 times 4x minus 3y, which is going to be 20x minus 15y equals 7 times 15, which is 85. Now notice, I don't want to add these two equations because if I add them, I'm going to get a minus 30y. My goal was to get rid of this y. So instead of adding the two equations, let's subtract the two equations. So we'll use a blue pen and we're going to subtract, okay? So we're going to take 27 minus 20, which is going to leave me with 7 x's. I'm going to have minus 15 minus a negative 15, which is minus 15 plus 15y, which is 0, y or 0. So we did get rid of the zeros. Now we have to take 78 minus 85, which is going to be a minus 7. And now we divide by 7, and we get x equal to minus 1. Once again, that's not our solution. We need an ordered pair, so we have to plug that minus 1 into either equation. Let's plug that minus 1 into here. So what we're left with, I'll write it over here, is where we get minus 4. I'm going to plug a minus 1 there. Minus 3y equals 17. Let's solve that one. We're going to add 4 to both sides. We'll get minus 3y then equals 21, or y equals minus 7. So our solution set for this last one is the ordered pair minus 1, comma, minus 7. Okay, so that's it in less than 10 minutes. So please note any questions that you have, ask them in class, and hopefully we'll get those answered for you. Thank you.